for the second part of Chapter 13, and this will be helpful in our lab over the next 2 days, talking about the oceans and currents, and we already talked a little bit about tides. So these are the questions, kind of the overall things that you maybe looked at yesterday. How salty is the ocean water? How do the temperatures and and then surface currents and deep currents. So as we take a look here, this, of course, fairly obviously, is a graph from the book, but I think it's pretty easy to look at this. So 35 grams, ocean water chemistry, we think of it as being salty, and anyone who's ever gotten a mouthful of ocean water, yeah, it's really salty. But it's not just table salt or sodium chloride, although that is mostly what it is. So ocean water, in 1 kilogram, which is 1 liter of water, so a 1 liter water bottle, 35 grams of salt. So 35 grams of salt, and sorry, I don't have it to show you, but 35 grams of salt is a significant amount in that. When we did the lab last week, I had measured it out, and 100 grams, remember 100 grams of the gravel was, you know, not quite full here. So a third of that, but that's how much salt in 1 liter of water, that's how salty the ocean is. So when you look at that, and then again, mostly, so sodium chloride, and then these other ones also make similar salts. You can have magnesium chloride, that's what we put on our roads to melt the ice. Calcium chloride, which is oftentimes in the ice melt you put on sidewalks, potassium, and other things. But that's what makes up the salt water. And other things that affect the salt water and what is in the salt, what can live in the salt water. Other things, temperature, which we'll talk about. Different parts of the ocean have very different temperatures. The amount of light. Light can only penetrate through the first part. It can't penetrate really deep. Gas is dissolved, especially, of course, oxygen. Any body of water has some oxygen in it. That's going to affect what can live there. And then density, which is going to be actually most directly related to temperature and saltiness. And all of these things are going to affect both what can live in the ocean, and some of that's going to affect our ocean currents as well. All right, so again, a picture from the textbook, and this is something we're not going to spend a huge amount of time on, but this does affect the ocean currents, as we're going to see and as we will demonstrate in our lab. But as you go deeper into the ocean, a number of things change, but you actually have very different zones where things can live. So you're going to have what's obviously the surface zone. So obviously the light can come, and it's warmer, it's got more oxygen in it, and many things can live in this zone. And you see here it says color and light. The sunlight penetrates. This is where you've got coral reefs and a lot of shallower animals. Then you've got transition zone. As you get deeper, obviously the pressure gets much greater because all of this water is pressing down on every side of you and every other thing there as you get deeper. In addition, the sunlight cannot penetrate as deep, which obviously makes it darker, also makes it colder. And so when you get very deep, there's high pressure. There is, it's more dense because of the salts and the colds. When things are colder, the molecules are closer together. So when you get way down deep here, in addition to being dark and cold, it's very salty, and there's a tremendous amount of pressure too. So the living things that live down towards at the bottom of the ocean are incredibly different from what lives up top. And in fact, if you bring some of them up, they actually can't live up here in the areas that would seem more habitable for us. So what's going to be important as we talk about currents are going to be salinity, which is saltiness, and density. All right. The two things that we're going to, so there's two major types of currents. There are surface currents and deep currents. The density and the temperature are mostly going to affect the deep currents, so we'll do that in just a second. So the surface currents are shallow currents. They shallow as in a couple hundred meters deep, and these are primarily caused by winds. And not so much just the local winds, and when we talk about weather, we'll talk a lot about the winds, but there's something called prevailing winds. And these are wind patterns that are consistent over long periods of time. So we know here that in Colorado, and in fact over most of North America, the wind generally blows from the west across. And so this is coming from the Pacific. These are prevailing winds. The prevailing winds are going to also affect the surface currents. And so what you see here are currents affected by the winds, affected by what's called the Coriolis effect, which is because the Earth is turning. It causes a turn in the currents, and then we are going to have some temperature effect too. So the Gulf Stream, so let's take, these are the major currents, and if you think about it, these are just like in the air. These are used for shipping, and they affect fish and migration and all sorts of things like that. Yes. Well, with the water pressure, so like the Titanic and other shipwrecks, they're down very deep. Part of it, so like submarines, you've probably heard, if a submarine, if there's problems and it goes too deep, it will actually crush at some point. So it's called crush depth, right? Because the pressure will literally destroy it. And so the Titanic obviously had issues and sank before it went down. But one of the reasons it took so long to find and is so hard to explore is because it's so deep, it's too dangerous and too difficult for humans to go explore. And so then when we have those awesome little, submersible robots, things like that, they can go down, and obviously it's not as difficult that, you don't have a human in there. They don't need oxygen. Their lungs aren't being compressed. They're not affected by the cold. And so being able to remotely operate robots like that allows us to explore things deep under the ocean that we couldn't otherwise, both shipwrecks and animals. But yeah, then obviously once it sinks, anything there gets probably crushed and twisted a little bit more. Not as much if it doesn't have air in the middle of it, right? Because just pressure on a steel wall is not going to make that much difference. But yeah, certainly for submersibles and that'd be a problem. All right, so here, and again, picture from the textbook, and we're going to look a little bit tomorrow's lab at the difference between the surface currents and the deep currents. So here you've got warm currents and cold currents that are going to affect climate. As we talk about weather and climate in a little bit, this will be even more important. But not too surprisingly, along the equator, we have warmer currents, right? Because we're talking about the surface, which is warmed by the sun. And so when you have this current going up here, up the east coast of the United States, is a warm current. And so that's going to make these areas warmer than a similar area over here that's getting a cold current. And it's kind of funny because there's this, even though there's a warm current here, there's a tiny cold current along the coast of California, making those not as pleasant of beaches to, I don't know, surf and stuff on. And again, so this is gonna, these are surface currents, and sailing ships and things like this. That's a major way people travel, and animals migrate and such. Questions about that? Obviously, they're affected by things like running into land and the Earth spinning. Then, deep currents. Now, the deep currents are really interesting because the major thing that's affecting the deep currents is the density of the ocean water. Now, here's the fascinating thing that happens. So, obviously, if the water is denser, it's going to sink, and if the water is less dense, it will rise, right? So what's changing the density of the water? Why wouldn't you just have cold, dense water that's salty? Why wouldn't you just have cold, dense water down low and warm, less dense, less salty water up top? Well, water is fascinating for, I suppose, a lot of reasons. But water, what happens to water? Most things as they get colder, they get more dense, right? What happens to water when it freezes, when it becomes a solid, which would normally be the most dense phase? It turns into ice. What happens to ice? But before that, it floats, right? Because ice becomes a crystal. And so what happens, you have these little water molecules, right? H2O. And what happens is when they're a liquid, they can float around and get fairly close to each other. Water is most dense at 4 degrees Celsius. Celsius is just easier for this, right? So 4 degrees Celsius, it's the most dense. But then when ice gets even colder, 0 degrees Celsius, it makes a crystal. And so what happens to these molecules is they line up in this crystalline structure. Remember, repeating crystalline structure. And because of just the nature of the molecule, it becomes less dense, and then it floats. So less dense ice. And this actually happens in lakes too, because you think about it, if the most cold, dense water was at the bottom of the pond or the lake, which part of it would freeze first? The bottom. And then it would slowly freeze from the bottom up, and all the fish would be trapped in this little, and ice fishing would be really easy, I guess. And if it totally froze, they'd just be all these dead things on the top. Would that be kind of messed up? So anyway, so what happens is you got a number of things happening. But as the water gets colder and denser, first it sinks, but then as it gets even colder, it freezes and it rises. And so that's one of the things that's happening. Then the other things that are happening, that you saw the surface currents, and the surface currents are taking water mostly from the equator north. And so then what happens is surface currents carry the warm water towards the poles, right? So it goes from here to here. So the warm water is going here where it's colder. Then what happens? It cools down and it sinks. And so then it goes this way. And then it gets to the equator and warms up. And so because of this, instead of the water being stagnant and cold and the same density in all the places, you have this constant upwelling and this constant circulation of all of the oceans on the Earth. So the deep currents are going to be caused by the surface currents, by the density differences, by the temperature differences. And what's the other thing that happens to salt water when it freezes? Actually, it doesn't get salty ice, does it? Yes, the ice becomes fresh water. So, and when water freezes, it's basically fresh water. So it becomes fresh water, which makes the water around it more salty. So you have all these crazy things changing the density and changing the temperature. And so it makes these deep currents. But again, what happens, we have a number of different things that end up affecting life on Earth. You have things called upwelling, where the water is constantly being stirred. And as it's stirred, nutrients come up from the bottom and feeds the fish. And the currents are constantly moving living things. And that's the lab we're going to do tomorrow. So as you read over this, we're going to have a few more minutes. You can look over it. As you do the lab tomorrow, there'll be questions along the way. But again, for those of us who live in a landlocked state and have spent most of our life here, these are kind of new and different ideas. But so surface currents, deep currents. Tomorrow in the lab, we'll get to see different examples of the density and temperature and salinity. Questions?